Okay, as mentioned last week, there was one thing that we forgot to touch on about my time back home, and that was
barbecue sauce.
Barbecue sauce.
Yeah, I mean, you're a mustard guy. It's forgivable. I'm going to let it pass on this case.
That was a very poor attempt at the Chili's ad. Barbecue sauce.
Barbecue sauce? No, it's does he say barbecue sauce?
Yeah, no, it's Chili's baby back ribs.
Chili's baby back. Yeah, okay.
Barbecue sauce. Okay, anyway. Power tools.
Power tools. I love power tools.
Power tools operated by barbecue sauce. I mean batteries.
Oh, it seems like in a big power outage, battery-based power tools probably not the ideal.
Yeah, well, this was after the power came back on.
Oh, okay.
For the most part, but it's not my first time. Like I've like they have a battery-operated lawnmower, and I've cut the grass before, so it's not my first time touching all this stuff.
Wow, really? Okay.
But battery-operated leaf blower, and this was the big one. In fact, this is really most of why I'm bringing this up.
Mm-hmm.
Battery-powered chainsaw.
Wait, really?
Yes.
Man, that sounds nice. Does it just make a good whirring cutting sound and there's no like?
Yeah, I mean it's still like louder than you might think.
Okay,
but it's not like that gas engine like extreme loudness. You know,
how long
like
does it last?
I don't know. We just got a couple of limbs down over the driveway and I cut those up, so I wasn't using it. I bet I ran it total for like 10-15 minutes.
That's better than I would have expected, I guess.
And actually, maybe the coolest thing about all this stuff is, and I guess like my parents like went out of their way maybe to make this happen, but the batteries are all basically interchangeable.
Yeah, so if you buy everything from the same company, you can make that happen. Yeah. My electric stuff is all hand tools because we pay somebody to mow the lawn.
Yeah. And of course, you still had to dump a bunch of oil into the chainsaw to lubricate the blade. But
well, yeah, because like I have to assume this isn't like a logging style chainsaw. This is like a trimming up stuff around your house chainsaw.
It's like it's a handheld. It's got the same form factor as you would think of a chainsaw having. Okay. But yeah, I guess it's on the smaller side. Like it's probably you're not going to cut a whole tree down with it, probably.
So we do have an electric lawnmower, but it's a plug-in, which is why I pay people to mow the lawn. Mm-hmm. Because having a 200-foot extension cord is kind of a pain in the ass.
Wait.
Yeah.
It's plug-in while operating? Like it only runs off the... Oh, wow.
Yeah, so I basically put the plug in and I chuck it the cord over my shoulder and I just dole out cord and roll cord back as I'm going.
Seems like the risk of running over the cord with the lawnmower might make things complicated.
I think that's probably a mistake you'd only make once.
Yeah, fair. Well, yeah, I don't think you'd be using the lawnmower again after that.
So how was your chainsawing?
It was good. It was like I haven't used a gas chainsaw that much in my life, but
they're terrifying.
Yes, partially because I'm afraid of them, and frankly, I was a little afraid of this one. But
there's a guy down the street from me that I see. He has a bunch of like scrub trees, and he's often up there with the chainsaw working on the scrub trees, and he does it wearing shorts. And I'm just like, man, that is a level of lack of fear of the tool that I do not understand. But
I was also wearing shorts when I used the chainsaw.
No, you gotta wear real pants, man.
Like how? I guess thick enough denim, it might make a difference. I was going to say if the chainsaw slips badly enough, I don't know that a layer of cloth is going to do much.
You want like leather chaps on there, man. You want something that's going to really bite into the blade.
Do they make plate mail for yard work?
You can get like Kevlar-ish gloves and stuff like that. But I'm interested in the electric chainsaw. That's an interesting idea. Is it one of those ones that's like also you can put on the end of a long stick and do like conversion on like trimming branches and stuff?
No, this was, like I said, regular. Like the handles are in the place you expect them to be. Like
okay.
It just looks like a chainsaw, except maybe a little smaller.
Oh, okay.
Yeah, it was fun. I'm kind of into it.
Yeah, I mean, look, you get a chainsaw, you can go cut down trees. You live near enough the park. You can cut down trees anytime you want.
That's right.
Welcome to Brad and Will Made a Tech Pod. I'm Will.
Whoa, I'm Brad.
I worked on my compressor the other day, so I can get wild up in here.
Doing a little live. I was just looking right before this. I think I'm finally going to buy that. What do we want to call it? A channel strip, a preprocessor.
It's a magic thing that lets you yell into your microphone and not clip. That's all I know about it.
Not blow out your audio and make people hate the way you sound.
Also, does it have a gate?
Yes, it has a noise gate.
Perfect.
It's got a compressor. It's got a I believe it's got a de-esser on it.
Oh, wow.
And like one other thing, it's a DBX. It's one that people in the Discord recommended. This is what we're talking about is if you have an analog microphone, like an XLR mic, I think we've talked about this before, but
yeah,
you can run that mic through a thing that kind of cleans up and massages the audio before it comes into the computer.
Which is nice when you do live stuff, it turns out.
Yes. Well, actually, so ironically, I've got a bunch of OBS has got some pretty good live filters for a lot of the stuff we're talking about. So actually my OBS when I stream is like fairly well cleaned up now.
But you got to have the CPU power to run that stuff because that's all. This is just a box that sits there and does it with magic.
Yes, but also it's a safeguard for these recordings because I clip on our recordings way more than I would like.
Well, and also having the noise gate, like when I'm doing podcast edits or something, and we have somebody who has a noise gate versus somebody who doesn't have a noise gate, it is a noticeable difference.
Yeah,
it's funny to me that there's not. I mean, okay. Your voice call stuff typically handles this. So like Zoom and Google Meet and Teams and all of that stuff kind of handles this kind of processing automatically, but it also makes your audio sound a little crap. So you don't want to record that for podcast purposes because we want to sound nice for you all.
Yeah.
But the I'm surprised that there's no like software stack that works like the OBS virtual camera that you can put between your, I mean, I guess NVIDIA Broadcast does this, but it also has some downstream consequences. So anyway, maybe there's something out there we just don't know about it. But
yeah, I've looked quite a bit. I was looking for like real-time recording plugins, like VST style plugins for like a limiter and stuff like that, and I just don't think that exists, or at least you need a way higher quality software than I'm using.
Or I mean, Voicemeeter does some of that stuff too, but Voicemeter has its own unique set of problems. So
hardware. Just chuck a box in line and let it do the work.
Here's a bunch of dials and knobs. Get turning.
Yep.
Brad, speaking of CPU utilization
and turning dials and knobs
it's finally the last of this year's CPU models are updated. Intel and AMD both have released entirely updated CPU lines, updated architectures. Intel's rolled out an entirely new architecture this year. Everything's disaggregated now.
Mm-hmm.
So if you don't know what that means, it means that inside your CPU package that you plug into your motherboard, there's a chip that has a bunch of other chips glued to it, smaller chips, and those chips can be made on different processes. They handle different parts of the CPU job, and it's kind of changed the way CPUs work over the last 5-6 years.
Yeah, traditionally they would fabricate one chip, and that one chip had literally everything that the CPU did on it.
Yeah, so traditionally you have a wafer. It's a big piece of silicon, special silicon. They carve some stuff into it. They do some baths, and it's all sorts of really toxic chemicals and gold and business. And then there's a bunch of little chips on there, and they cut each of those out of that big wafer, and then each of those little chips gets glued onto this package, and then it becomes the CPU of your computer. Now,
right. So like, in the past, it was just the one chip getting fabricated that did everything. But now they fabricate a bunch of different chips, like you said, sometimes at different sizes, because not everything on the CPU needs to be tiny necessarily. Yeah. And then they get aggregated together onto a package.
Yeah. So AMD's been doing this for a long time now. This is their 5th generation of those. They started with the Ryzen years and years ago. It was a little hinky in the early days.
Yes. I'm glad I didn't, like, you read stories about the 1st and 2nd gen Ryzens and it sounded like a real mess.
Well, and the first and 2nd gen Ryzens, part of it is that things that hadn't been a problem before were suddenly a problem, like latency between CPU dies or CPU cores. And AMD did a really good job of reaching out to software developers and OS operating system providers and a bunch of other people to kind of work around and work through those kinks until we're in a pretty good place with it now on the AMD side.
Yeah. Yeah. And it's probably worth pointing out. I mean, people might be asking, like, what's the benefit of this stuff? Like, I think this is a big part of what's gotten us to much higher core counts on consumer CPUs, because previously having a ton of cores was the domain of like big workstation chips and server parts.
And big clock speeds too. Like this is why clock speeds continue to improve, is because thermal management at different, like you don't have to build an enormous 8 billion transistor CPU all on the most expensive process in the world. You can do the parts that are not as expensive to build on. Process in this case is the kind of resolution of the chip etching. So how small the the little traces and stuff are on the CPU.
This also on the manufacturing side, this increases yields because, you know,
right.
Some chips that come out of the fab are bad. And if the entire chip is one chip, then you have to throw the entire chip away. But if it's a bunch of different chips, you can theoretically, you have more good chips to plug together. Now, do they pass those savings along to the consumer? Maybe.
I mean, the chips keep getting faster is the savings that we get as consumers.
Fair.
Asterisk.
Fair.
Now, so on the AMD side, the new chips are the Zen 5. This is the Ryzen 9000 series chips. And there's, let's see, 16 core, 8 core, and 6 core versions of that. On the Intel side,
I'm sorry, did they not do a 12 core for Zen 5?
Sorry, they did do a 12 core.
Yeah,
it's
okay.
two. So we'll talk about it in a minute. But on the Intel side, this is Arrow Lake. These are called the Core Ultra S Series 2.
Yeah, this is where they also have dumped the i5, i7, i9 branding is totally gone now, right?
Well, but but the 7s and I guess the 7s and 9s are gone. Yeah, they have. They're using the same branding as on mobile now, basically. So the difference is that the desktop parts have an S in the name, where the mobile parts don't.
Okay.
And then there's some other letters that come up in the name. Like if it has a K, it means that it's overclockable. If it has an F, it means there's no GPU.
Do they always use the word ultra? What I was getting at is effectively they've dropped the I. Like it's still Core Ultra 9 285K for the top end part, but it's not the i9 anymore.
Yeah, the i9, the I is gone. The people just refer to these as the 285, the 265, 245.
Yeah, what I was wondering though is, does the Ultra label denote anything in particular? Like, does that mean like it has graphics or it does this or that, or is that just marketing?
I think Core Ultra means it's the disaggregated one because Core has been around for a long time.
Okay.
I would have to look to be sure, but ultimately the branding doesn't matter.
Yeah, it's just CPU branding is always confusing, so you have to kind of like read some tea leaves to make sure you know what they're talking about.
Yeah. And then the other wild card on all this is that AMD does this thing with an enormous cache that they glue onto the chips to make them really fast for games, basically. They're fine for other things. In the past, these are the X3D parts. They just rolled out the first of the X3D parts for this generation, the Ryzen 9800. The TLD. So we're going to unwrap the onion, unpeel the onion this week, and we're going to give you everybody the high level here first, and then you can drill down further if you want.
We could just core straight to the center of the onion right now really quickly and just say, if you want a gaming PC, just get a 9800 X3D.
That's the answer.
Now you can turn off the podcast.
Yeah. And if you care about a lot of cores, then and do a lot of like workload stuff that requires a lot of CPU cores, the Intel stuff is okay, but you might be better off going with last gen. You got to look at the benchmarks a little bit and see what the things that you do matter for.
Yeah.
And then the high end big core Ryzens also are fine.
Yeah.
So now why is all that the case?
Why is all that the case?
Well, let's start. All of these launches had problems, with the exception of the X3D part. The Ryzen 9000, when they came out a month and a half ago, they messed up some testing stuff that caused everybody who was doing the benchmarks to get lower than expected results.
When you say expecting, you mean lower than AMD was expecting? Because like they provide numbers to testers and say, hey, this is what we got. This is what we think you should be seeing. But then.
Yeah, we think of those as kind of sanity check numbers, so that when you're doing testing, if you have something that's way off of what they're like, for example, benchmarks like Cinebench, which is a heavily multi-threaded benchmark, are really repeatable and an easy way to tell if there's something messed up with your BIOS settings or your Windows configuration or something like that. And we were seeing numbers that were like 9% lower than the provided sanity check numbers, which is pretty unheard of.
It was bad. I mean, like, if you get into the like slightly more contentious regions of YouTube hardware reviews, like you were straight up seeing video titles just like Zen 5 sucks, like Ryzen 9000 fail.
So there were a couple of reasons that happened. One is that AMD was running their tests as the administrator account versus an administrator account, which had never mattered before.
What?
But something changed with this release that caused the administrator account to have a pretty significant performance advantage over just running as an administrator.
Weird.
I don't know why that is. They've stopped doing their sanity check tests as the administrator. You shouldn't run as the administrator account in Windows. please don't do that.
Oh, well, we're talking about it like not a administrator enabled user account at all. Is it some kind of like
I'm talking about the user named administrator, which is built into every Windows install.
That's right. Yeah, if you look at like file permissions, you'll see that account, right?
Yeah, it's kind of like running Windows as root, but you shouldn't do that, right?
Right.
It's not exactly the same. Anyway, so we at PC World, we were doing our benchmarks and we saw numbers that were off significantly enough that we thought we had messed up our testing process. And as a result, we ended up doing a live stream the day of the embargo, but we did not release our review at embargo time because we thought we'd messed something up. And then we looked at everybody else's numbers and they got the exact same results as us. And we were like, oh, well, we better get this going. The upshot is AMD did a post a couple weeks later explaining what had happened exactly. They went through it. There's also been some Windows updates for 23H2 and 24H2 that changed the way branch prediction works.
Yeah.
They're not there. You should have, if you have one of these processors, including Zen 4 dual CCD chips, which we'll talk about in a minute, you'll get a pretty significant performance boost by running this stuff.
Yeah, and I want to say, I don't have it in front of me, but I think, didn't they backport this fix to even like, I believe Windows 10? Like, I think it was pervasive enough that they were like, hey, we need to make sure this shouldn't be something we hold back for modern Windows 11. I think everybody needs this.
I think it's just 23H2 and 24H2 last I saw.
Maybe you want to be on Windows 11 then if you have one of these, but if you care, branch prediction is the thing where, do you know much about modern CPU design? It's the thing in the pipeline where CPUs kind of pre-compute multiple outcomes for the instructions they're running, kind of like in a control flow kind of way, like an if-then sort of thing. Like the CPU looks at what instructions are being pumped through it and kind of goes ahead and does both versions of the math or whatever,
and then switches back to the one that ended up being right,
and then just takes whichever, just discards the unneeded result and goes with the one that was correct. It's part of how performance has continued to increase over time. Anyway. That's my like not a computer scientist understanding of it, but apparently something about Zen 5. Actually, I've got the quote here from AMD. The Zen 5 architecture incorporates a wider branch prediction capacity than prior Zen generations, and then they go on to basically say like that's what they were optimizing around in Windows with this update. So it is a legit hardware improvement. This is not some smoke and mirrors type of thing.
Yeah, no, and if you install the updates for Windows, then you'll see the same similar impact. And also worth mentioning, it impacted the chips with two compute dies, the dual CCD chips, like the 9950 and the 9900, more than the single CCD, although it does show improvements in the single CCD chips when you install it. Anyway, that's the TLDR. Now, like you said, there were a lot of people saying, is AMD screwed at the end of this? Part of the issue, I think, with this is also that they locked the single die chips to 65 watts TDP, which is pretty low for a desktop part. I don't think that's ultimately a bad thing, but
that's music to my ears, honestly.
Yeah, it's the downside is that the numbers were not between these two things, between the 65 watt and the performance problems related to the branch prediction stuff and the admin account. They were coming in like 9% under what they expected, and those numbers looked exactly the same as the 7000 series, or somewhat worse in some cases. Since the release, AMD has come out and said, hey, if you want to run the PBO mode, which is their precision boost overdrive, which is basically like built-in overclocking, it's a little more configurable than like it's not, hey, I'm going to open this up and turn the multiplier up, or I'm going to open this up and turn the bus up. It's, I want to run as fast as you can and keep the CPU under 80 Celsius, right? Like, which if you have a big cooler attached to it means you can get some really nice performance boosts without any danger to the chip or whatever. They've rolled out and said, we're going to honor warranty for people who have flipped PBO on and cranked up their TDP on the 96 and 9700 to 105 watts, which is what the last gen parts shipped at.
Yeah, or actually was 105 the eco mode on Zen 4? I want to say that's
for the high end parts, yeah, but for the low end, it was it was what it shipped at.
Right, but the point is, even 105 is not that high by the standards of modern CPUs. So, like the fact that you can get very good performance at 65 or 105 watts is like a pretty damn huge improvement in efficiency.
Yeah, if you care about efficiency, everything that we're going to talk about today is good.
Yeah.
If you care about performance,
Yeah, I would. Yeah, but maybe we'll get to it more when we kind of wrap this up. But I think a general reset on efficiency to performance ratios was needed.
Well, especially after Intel was burning the world down with the Raptor Lakes. Yeah.
And AMD briefly did that with Zen 4 as well. The point is, like, everybody was playing too fast and loose with voltages and power consumption to try to eke out like 0.1% more benchmark.
I compared this to the steroid era in baseball the other day.
Okay.
Where, after you used to Mark McGwire and Barry Bonds and Sammy Sosa just teeing them off constantly for years and years and years.
Yep.
Maybe it's going to be a little more, maybe we have more pitchy games for a few years here, right?
See, the CPUs have been juicing for too long.
That's what I'm saying. So, okay. So overall, Zen 5 Ryzen 9000 is a kind of incremental advancement to Zen 4. They have the branch prediction enhancements.
Yeah.
They add full AVX 512 support, which is a new instruction set.
Oh, was that not in? I thought Zen 4 had AVX 512. Although, well, I'm getting out over my skis here. I think it was like maybe limited in some way.
It was not a full implementation, is my understanding.
Yeah, I should say. I mean, this doesn't matter to consumers typically, but like when you say Zen 5 is an incremental improvement, like on the benchmarks, that's true. My understanding is that it's the first like new from the ground up architecture since they've moved to Ryzen, though. Like Zen 1 through 4 was all like iteratively improved on from the same design, and Zen 5, I believe, was a pretty much like a brand new microarchitecture. So it's the foundation for the next several years of Ryzen's is the point.
Yeah. So they doubled the cache bandwidth versus Zen 4. They rearranged how things connect on the chip in some ways that make that possible. It's a 4 nanometer process size. And all of these chips have 28 lanes of PCIe 5 out of the CPU, which is a lot of PCIe 5 lanes.
Do you know what it was on Zen 4? I don't know, like the 20 comes to mind. I'm not sure if that's right. I had a Zen 4 for some months, and I feel like it was like 20-ish on that 7950X3D I had, but I can't remember. Anyway, that's a lot of lanes. That's a good, generous number of lanes. Now, if only motherboard makers won't devote all of them to M.2, I'll be happy.
Well, I mean, I think the point is you can get an M.2 and a 16 lane PCI Express slot and still have some stuff left. Maybe you have two M.2s that are 5 PCIe 5 or whatever. The Ryzen 9 dual CCD designs also get stuff that was limited to the X3D chips in the past.
Oh, really?
So this is one of those, hey, this is kind of good, maybe not for everyone features, where if you have the right stuff installed on Windows, when you do something that needs to run on one. So, okay, we should take a step back. When you have these dual CCD designs where they have 2 8-core compute dies, right? So you can get 16 CPU cores with 32 threads total between them because hyperthreading is enabled on these chips. Then you can, if say a game is running part of its threads on one of these dies and part of its threads on the other, you see pretty significant performance impacts because of the cross die communication being a slower speed than intra die communication. Right.
Yep. Which is important to understand this because when we get to Intel, they are doing things differently here.
Yeah. With the X3D chips, because they put the cache on the dual CCD chips only on one of the CCDs, they would just turn off the die you weren't using and crank up so the game has to run on the CCD that has the V-cache on it.
Yes, or at least theoretically. Now, I had one of those chips, like I said, and I never ran into this problem. Like, this never really seemed like an issue to me, but some games, the other CCD would get unparked and threads would kind of migrate over anyway. Like, that was kind of something people were frustrated with, was like, okay, not every game actually knows how to do this correctly, and you're still getting problems. But I never really saw an issue with it.
So when I said this is these disaggregated designs are hinky and have required a fair amount of work on the part of ISVs and OS vendors to make everything work the way you'd expect, this is a perfect example of that, right?
Yep.
In order to get this to work, you have to have the right BIOS, the right chipset driver. You have to have Windows game mode turned on and a new version of the Xbox app. And if that all happens, the Xbox app says, hey, man, you're running a game. I'm going to put in game mode. And game mode says, oh, OK, if you're running a game and we're in game mode, then we got to do this. And it turns off the slower CCD.
Theoretically, that entire stack will make that work. Like I said, though, I would see the other CCD get unparked in the middle of games sometimes. But the thing I never saw was I never got like significant hitching, which is the type of thing you would see when threads were misbehaving and stuff. So
and part of the challenge is that Windows just fundamentally doesn't exactly understand what's going on in these chips, right? Windows at its core thinks that all CPUs are created equal because that's the way they've been for a really long time.
Scheduling is hard.
Yeah,
it turns out
it's a problem in this design. It's also a problem on the Intel design because they have the big cores and the little cores, and that's complicated for other reasons we'll get into in a minute.
Yeah, like I've got an Intel chip with big and little cores in my server.
Yeah,
and because I'm this kind of nerd, like I watch some of the like Linux kernel mailing list development chatter. Like, because like Intel has a ton of engineers that contribute to the Linux kernel, for example. Like every hardware company contributes to the Linux kernel, but you still to this day see Intel engineers talking about tweaks, regressions, like new X, Y, and Z things they're introducing. Like they are still, even on the Linux side, like working on kind of heterogeneous scheduling between different types of cores. Like it's a hard challenge to solve, hard problem to solve.
Yeah, and
getting the OS to know like which applications need more priority, which ones can run like on lower cores, like blah blah blah. Like it's not an easy thing.
It's to the point that like Intel on the server side for data centers, partly for power reasons, but partly just because it makes some applications easier, are building chips that are all P cores or all E cores, all big cores or all little cores for different applications. Because sometimes you just want something that has a whole shitload of threads.
Yeah, don't they have some server part that's nothing but like a bajillion E cores?
Yeah.
Like a horrifying number of E cores.
That's mostly to go in old data centers that have lower power requirements for each rack. But anyway, okay, so 2 new chipsets announced when they rolled out these CPUs. They just came out a couple of weeks ago.
Yeah, that's crazy. I mean, I know AMD does the thing Intel never does, which is, although Intel did do this with 1700 socket, but
I don't think that was intentional for what it's worth.
I think that was more they were forced into it.
Yeah.
But AMD does the thing where, multiple generations of CPU can run on the same board. But I don't know that I've ever seen it where they didn't put out new motherboards at launch of the CPU. It was like 2-3 months of you had to buy an old last gen motherboard to even use these things.
Yeah. So AM5 is the socket. It's going to be around. They've said we're going to support this until 2027 at least. I think 2027 plus is what the slides say.
So that's at least one more generation after these Zen 5 parts, if not 2, maybe.
I mean, and for what it's worth, they announced new AM4 CPUs this year.
Yeah.
So like,
didn't they announce a new Zen 3 part in the last month?
I don't know about that. That sounds crazy.
I thought I saw that. I could be wrong.
But anyway, the X870 and X870E chipsets are out now. They all have USB 4. They're specifying the USB 4 chips, I believe, that are allowed to be used by the motherboard vendors for at least some subset of the ports.
Really? You mean third-party USB controllers?
Yeah. Yeah,
really?
they had a list of here are the controllers that are going to be supported on their deck.
Interesting. Okay, I wonder because the USB compatibility was probably the biggest problem I had when I was on AMD. So if they're devoting attention to making that better and more compatible, that's very good.
I think this is one of those situations where Intel builds a lot of their own USB chipsets, and AMD does not.
Yeah. I think that's probably the case because I have had infinitely better experience with USB peripherals on this Intel machine.
Yeah, I think like my board has Intel USB chips on it, I think. Anyway, and PCIe Gen 5 for graphics plus NVMe is standard across for multiple NVMe slots and the main graphics slot.
Yeah.
And I think it has Wi-Fi 7 support as well.
We talked about it on the Wi-Fi 7 episode a few weeks ago, but every X870 board I looked up had Wi-Fi 7 built in. Although I don't know, I wonder what the market spread is on people using Wi-Fi on desktops.
It's surprisingly high, would be my guess.
I think so.
Yeah.
Well, some people just don't want to run Ethernet cords. Right?
Some people can't run Ethernet cords,
or don't have the layout that supports it.
Yeah. Faster memory clocks supported on the new chipsets as well, up to 64 mega transfers per second.
6400.
6400. Did I say 64?
Yeah.
64 mega transfers per second would be very low.
That would be pretty slow.
Yeah, that would be unfortunate. But 6400.
No, that's supported, right? That's like out of the box spec 6400.
That is JEDEC spec 6400 mega transfers per second. Yeah,
because you were seeing people go 8000 or higher even on the previous gen, but that's like way out of spec. That's kind of overclocking territory.
And you have to turn some ratios down so that you're doing like a limited number of transfers or run single channel mode. There's goofy stuff you do when that happens.
Yeah. So 6400 supported out of the box seems like it's getting there.
Like officially rock solid support is the thing. There's 4 parts out now. I'm sure they'll fill out the stack more later as time goes on. The high end is the 9950X, which is a 4.3 gigahertz to 5.7 gigahertz, depending on boosts and how many cores you're running and all that. For $600, it's 16 cores with hyper-threading. So that means 32 threads on 2 CCDs, 2 dies. And it's 170 watts total TDP. The 9900X, which is 4.4 gigahertz to 5.6 gigahertz, has been dropped to $430 already. I don't know if that's permanent or not, but that was the this one is underperforming compared to the other people's price. Is 12 cores with hyperthreading on 2 dies. The 9700X is a single CCD 3.8 to 5.5 gigahertz for $330. And that shipped at 65 watts TDP, but that's one of the ones that you can overclock to 105 using PBO, and they'll honor the warranty on. And then the 9600X is a 6-core version of that same thing, 3.9 gigahertz to 5.4 gigahertz for $250 with hyperthreading, 65 watt TDP, again, overclockable to 105.
Yeah. I know this is just branding, but it seems like they have possibly now reserved the 800 label purely for the X3D chips, because it used to be the 8-core was an 800. It was a 5800X, 7800X. Those were the non-Vcache 8-core parts, but it looks like they've moved to 9700X. I guess that's just to make it more obvious which one is the good gaming one.
So we can talk about the 9800X now if you want, X3D now if you want, because they kind of did a surprise right as Intel was rolling out their Arrow Lake CPUs. They were like, hey, by the way, guys, we got an X3D coming. It's going to be here week after next.
Almost like they planned it that way.
Yeah, it was real suspicious timing.
I guess it does make sense to do all the AMD stuff now, even though we're kind of leapfrogging the Intel stuff, which we'll get back to. The other thing I was going to say real quick is that I still find the 12-core part a little weird here. Like,
I'm sure that's hey, we have some dies that fail.
Oh, yeah, for sure. It's absolute. Well, I think it's a 6-core CCD that they put in that thing, right?
I believe they don't specify a 6-core.
Or do you think they're only fabbing one 8-core CCD now, and like they're the ones that have bad cores, they're just dropping down to 6?
My guess is that they have ones that have bad cores that fail, that they're dropping down to 6, but I don't know.
I'm sure people have delidded these things and looked at the dies by now to maybe figure that out. I'm not sure.
Yeah.
I mean, I know this doesn't matter to the average end user, but I mean, we're not average end users. We're huge nerds, and I just am curious about this kind of thing. But the bigger point though with the 12-core one is you're still having the 2 CCDs, so you still have to worry about threads migrating across and taking a performance penalty.
Yeah.
But especially for games, like the consoles are all 8 cores now, so like I always feel like a 6-core die devoted to gaming is maybe shortchanging you a little bit. I mean, these are not gaming parts, to be fair.
I think that the 6-core stuff made a lot more sense before the current gen consoles were out.
Right.
Like, okay. I think that as we're looking at games that like hit all 8 cores, there are a pretty substantial number of games that are multi-threaded enough that you actually see eight CPU cores in use now.
Yeah.
And I would not probably buy one of those 6-core machines if you're looking at playing games. Now, if you're just doing multi-threaded stuff, like it's a pretty substantial price drop from the 9950X with 16 cores
to get 12.
To get 12. Yeah.
If you're doing like video encoding or Photoshop or like productivity stuff, should be fine because those are way less latency dependent than games.
Yeah, it's like, but even like video encoding is less of a hey, I need a lot of CPU cores thing for it these days because most people are doing that on the GPU. So it feels like it's like rendering and stuff like that.
Yeah, well, it depends on if you're doing like streaming, you're on the GPU. If you're encoding for maximum quality, you're probably still doing software encodes.
I think you'd be surprised.
Yeah, I mean, there's still the hardware encoders are much better, but
yeah. Anyway. So the 9800X3D is a $480 MSRP. It's $30 more than the 7800X3D at launch. The 7800X3D is basically impossible to find now. Like these seem like they stopped making them.
No kidding. Okay.
It's a new 3D V-cache design. It's the first time they've done that since they launched the 3D V-cache stuff.
This is huge. I did not realize they had done this.
Yeah. So previously the 3D V-cache was on the top of the chip, which meant it was basically like an insulating layer between the hot part of the disaggregated chip.
Yeah, like the actual chip, like the actual
compute
CPU
part of the chip
cores were buried underneath the extra cache, which is a strange design choice.
Well, and as a result, you couldn't run those at quite as high a clock. So if you had a single CCD design, like a Ryzen 7800, for example, then you would just know that you're going to sacrifice some clock performance, some upper bounds of that, because the massive amount of L3 cache on this V cache gave you enormous performance in game and stuff that's like memory latency sensitive, like games and things like that. Now, if you had a dual CCD design, you were in a weird situation where Windows didn't know where to put stuff because your non-V-cache cores would be way faster, like dramatically compute stuff.
Yeah, because that's what I had, like, and it was like 600 or 800 megahertz difference, I think, between the non-V-cache die and the one with.
Yeah, and as a result, if Windows put your threads on the right cores, stuff was great, and if they didn't, then you were running at non-optimal speeds.
Yeah, and in fact, what you would see, because I watched, Task Manager and stuff a lot, like you would see, I believe they parked the Vcache die in Windows normally.
Yeah,
because you want all your Windows tasks on the die with a higher clock speed, right?
Yeah,
so like
exactly.
You were only running on the 8 cores of the higher clock speed die unless it needed the extra 8 cores. Like it was a weird split thing. And worth pointing out here, the X3D parts on Zen 4, they launched 8, 12, and 16 core parts all at once.
Yes, and it was like 6 months later, 5 months later.
Well, it was some time later, right? But the point is they have only launched the 8 core part now.
Well, that's what people wanted, the 8 core part.
That's exactly it. I'm wondering if the 7800X3D outsold the 12 and 16 core parts so much that I wonder if they'll even bother this time.
Well, so the thing about the 8 core part is that the 8 core part is faster. Not to skip to the chase, the 8 core 7800X3D from the Zen 4 generation is faster than pretty much anything Intel launched this time and anything AMD launched except for the new X3D part in games.
Yeah.
So it's an incredible, the Vcache is incredible for games is the kind of TLDR.
Yes. Real quick, just Googling around, it looks like there are benchmarks leaking for the 16 core X3D part. So that probably is happening.
So the new design is that they put the Vcache on the bottom of the chip. So it's no longer insulating the dies, which means you get a base clock that's 500 megahertz faster than before, and it's unlocked for overclocking, which is new. It's really, really, really good for games. Like it's the first of all of the CPUs that have come out so far this year. It's the only one that the enthusiast gaming channels have been like, this is a real good CPU. Everybody should get this. And the overclocking results for it are kind of crazy.
Huh. That's cool. I'm flipping the cache to the bottom is a huge thing. That I'm glad to hear they did that.
Yeah, I think they pitched it as, hey, this is the first time we've redesigned this since we started doing the Vcache, the 3D Vcache stuff.
Worth pointing out that not every game is going to see massive gains from the extra cache. Like it's very dependent on the type of game.
Yes,
and specific game engines, even like strategy games, anything that does a ton of like math constantly, Factorio or like Civilization type like 4X games and stuff. Like just like huge gains, and a lot of like 3D action games as well also get a huge boost. But there are some other games that see next to no improvement on the X3D.
Your 2D pixel art games aren't going to see a whole lot,
or even like certain 3D. Like I want to say I think the Far Cry games, for example, like Ubisoft's engine doesn't see much of a lift. Like it's highly game dependent, but it is a lot of games that get a huge boost.
So the TLDR is if you just want a kind of general all-purpose CPU and you play games, that X3D at $450, $500 is a pretty good deal. They're sold out everywhere right now.
Yeah,
you can't get them anywhere.
I think how long's it been out at the time of this recording?
So 3 days.
Okay,
2 days.
Yeah, that makes sense.
Yeah,
but I assume they'll be making a lot of these because they are going to sell a lot of these.
Yeah, this is how they gain market share against Intel in enthusiast spaces. It's a small part of the market, but it's one that they seem to care about quite a bit. So that's what AMD's got going. I like these chips are pretty good. The power efficiency, I actually really like that they ship them at 65 watts versus 105. Because this is a situation where defaults matter, and the vast majority of people who buy a 9600 or 9700 don't care that it's only the same speed as last generation part. And like, it'll be nice that their rooms are less warm and they're not wasting as much electricity doing the same exact work.
Yeah. And they're not risking their hardware.
Yeah.
Because again,
but if you want that perf, you can, right?
Right. Like, as both companies have had examples in the last 2 years of CPUs committing suicide because of the amount of juice they're
wildly different scales at which it happened.
Well, I know. Yes. But it shouldn't be happening at all anywhere ever.
That's true.
So for them to take steps to alleviate the problem is extremely welcome.
Yeah. Okay. Next up is Intel's Arrow Lake, aka the Core Ultra S Series 2. They skipped the 100 series for reasons that I don't understand. I
wonder if is it because Meteor Lake was technically the first generation where they did the disaggregated, but that was only in mobile and laptop.
It's possible. This is technically, like, Lunar Lake is the mobile part that came out earlier this year. This is actually I think a follow on to the Meteor Lake more than the Lunar Lake. The Lunar Lake is a different thing.
Arrow Lake is descended from Meteor Lake, is what you're saying?
Arrow Lake, it comes from Meteor Lake, is my understanding.
Interesting.
The chiplets are built by TSMC on a variety of processes, 3 and 4 nanometers rather.
Yes,
which is
I think up to 6. I think at least one of the tiles. So just terminology. Intel calls their little chips tiles that go on their disaggregated packages. AMD calls them chiplets, or at least chiplet is their kind of colloquial term.
Yeah.
But I think some of, there's like an IO tile and a memory controller and blah blah blah. I think it's like between 3 and 6 nanometers.
Yeah, I think that's probably right. And TSMC makes all of those, which is the first time that's ever happened for an Intel desktop part.
Yeah, except for I looked it up, the base tile, which is basically just the interconnect that all the actual tiles sit on, is made by Intel. But I didn't realize literally the entire rest of the chip is made by TSMC. Like, that's like big from a historic perspective and a business perspective, because like Intel has always made all their own stuff, and their fabrication traditionally has been extremely capable and has high capacity, but they have fallen so far behind on that front. It's like
Dr. Ian Cutress over at Tech Potato has a really good video about why this is a big deal.
Yeah.
Because Intel doesn't just make their own stuff. They also have a completely different process for like how the designs are transferred to the machines and the fabs and all that stuff. It's impossible to overemphasize what a big deal it is.
Like it's kind of like they are kind of eating crow, right? Like it is sort of an admission of, maybe failure is too strong a word, but like they have really fallen behind the market to have to go to TSMC to make this thing.
Well, they were able to be iconoclasts for a long time, and finally, as often happens with companies that are iconoclasts in an industry at this scale, it caught up with them.
Yeah,
right.
And there's a whole story there about who was running Intel for the last decade and how complacent they may have gotten and blah blah blah.
But also, like, they had a fab process that this was supposed to roll out on, at least part of it, that flopped, and they had to cancel, and then they're moving future stuff to a different process.
Yeah,
and like it's difficult. Like, I don't think we need to get into why Intel's having problems right now. But Intel is having problems right now that are related to some management stuff over the last decade.
For sure. I mean, I think it's enough to say that they are having problems, but they also, like you said, they've got this new process spinning up that's supposed to be pretty competitive with TSMC. They're also but they are building a ton of fabrication in the United States.
Yeah, which is taking longer than expected, which is costing them a bunch of money, which is anyway.
They got in big on the CHIPS Act, which God knows if that'll survive the incoming administration or not. But I think Intel's supposed to be getting like $3 billion from the government to spin up all this new fabrication in the United States.
Yeah.
The point is, like, they have their own process that is supposedly going to be competitive, but it may not be online for another year or two.
It's taking time.
And my understanding is, the little bit I've read, like the thing you were talking about with the way designs are transferred to kind of industry standard inner workings of the fab process, like they are getting more standardized on that stuff as well.
That is part of the thing that's changing as well, because they want to be able to get other people's business as well as just Intel. Typically Intel built Intel chips on Intel fabs, and nothing else was built on Intel fabs because their tooling wasn't set up to accept files from other.
Exactly.
It's like they were using WordStar still, and everybody else has moved on to Google Documents.
Right. Like that all, like, to my mind, like, that's actually all pretty important. And I'm not gonna even get into the national security conversation about having fab in different countries, but even just like the thing you always hear is that Apple and Nvidia are just completely dominating TSMC's output, like, because the phones, like Apple mobile stuff and Nvidia AI stuff is so in demand that everybody else just has to like fight over the table scraps of whatever capacity is left.
Well, so, and you're in a situation where you're buying capacity years and years in advance, right? Like this stuff is scheduled for, like, by the time the fab opens its doors, its first 5+ years of time are probably booked.
Right. And like, I'm not going to place the bet that Intel's new stuff is going to be like directly competitive on day one, but like more next generation fab capacity in more places just seems good from a demand standpoint, if nothing else.
Well, and from like a natural disaster, and there's like you said, Taiwan is challenging for a lot of reasons. Okay, so this is the first whole new design, ground up, soup to nuts redesign from Intel on desktop since like Nehalem, which was early 2010s.
Wait, Nehalem was not the first dual core part, right?
It was the first real dual core. Okay. Previously, it was that they had two CPUs on the same chip that talked through memory or Northbridge or something. I can't remember specifics, but
yeah, because I was going to say this is basically like from a basic level, this is the biggest design change Intel has made since they went to multi-core CPUs.
Since they went to real multi-core, yeah. There's new so this uses, like I said, it's disaggregated just like the Ryzens have been for ages. There's a Foveros is their kind of underlying 3D packaging tech that they've been talking about for years, and this is the first thing that ships on it for desktop. There's the tiles connect to the Foveros layer, or the interposer layer, base tile. They call it 4 different things at different places.
Yeah, I love the term interposer.
Yeah, it sounds so high tech. Good. But there's a system on a chip tile which has like the basic housekeeping stuff. There's a compute tile. There's an IO tile which has the memory controller and that stuff, I believe. PCI Express lanes, all of that, and a GPU tile that's optional. And then sometimes they also put a filler tile in that makes the whole thing nice and square. I don't understand why that's necessary, but I guess it is.
Yeah. So this is the thing I mentioned earlier where they differ significantly from AMD, at least for now. All their CPU dies all their CPU cores are still on one die.
Yeah, single die. And it's the 3 nanometer Intel, 3 nanometer TSMC package, I believe. So I for now, at least for as long as they're going to do that, I guess that avoids the problem AMD has of different dies with CPU tile, a lot of terminology. Different CPU cores on different dies trying to talk to each other over a slower interconnect. Like Intel, for the moment at least, does not have that problem because every CPU core is still on one chip. Well, because the thing to remember always is that as you get further, like when you're inside the same piece of silicon, you can talk at an incredibly high speed across CPU cores, right? So, for example, on the P cores that are in this new package, you have 33 megs of L2 cache each, right? And if one of those P cores wants to talk to another P core, it goes out to the L3 cache, which is shared with all of the L2 caches in the system, 36 megs of that. With the E cores all share 4 megabytes of L2 cache in each of these 4 CPU core clusters. So that means those 4 E cores can talk to each other very, very quickly across this L2 connection, which is a lot faster than the L3 connection that the P cores are using to talk to. Here's the thing. The upshot is it's way faster to talk through the L3 cache between these cores, no matter which core you're talking to, than it is to go out to that Foveros layer and talk to another chip on the die on the same CPU, CPU.
Yeah, on the AMD side, they call it the Infinity Fabric is the name of the interconnect between chips.
Yeah, but Infinity Fabric is slower than talking to cross L2 cache inside the chips. Anyway,
enormously.
So these are SkyMod E cores, which are supposed to be significantly faster than previous gen E cores. And the thing about the E cores and the P cores is the E cores are smaller. They're less capable in that they sometimes don't have the same instruction sets accessible to them as the P cores do. They have different cache configurations. They're mostly there to run on benchmarks where you benefit from having lots of CPU cores on workloads that you benefit from having lots of CPU cores. So your video encodes, your rendering, stuff like that.
Yeah. Everything I've seen is that, like, for whatever other problems Intel is having, like they're the group that's doing the E cores is just going ham.
I think that's a fair assessment.
Like the E cores, the SkyMod E cores are like very good. And And that is, I'm trying to think. I was keeping track of this for a while because like I've got this Alder Lake, for example. As of Alder Lake, I can't remember which Mont it was. That might be Grace Mont. Anyway, the E-cores in the Alder Lakes, which are 12th gen, were said to be about equivalent to a Skylake desktop part,
which was
a 6700K.
Yeah.
So basically, the cores, even a generation or two ago, the E-cores were roughly equivalent to a high-end desktop part of what, 8 years ago?
Yeah.
When did 6700 Skylake came out in 2015?
Yeah, it's 9 years ago.
Anyway, the point is the E-cores are getting like very capable themselves.
Well,
and you wouldn't want to play games on them, to be clear, but
I mean, you'd probably be fine depending on what kind of resolutions you're playing on, stuff like that. The point is the E-cores this year is supposed to be 30% faster than previous years.
Which is because, again, they were getting pretty good. And part of the reason I'm harping on this is because there's like, I think people probably are getting familiar with this. There's this whole scene of like lower end fanless x86 boxes.
Yeah.
Coming out of like AliExpress and stuff. It's like things that people are building routers out of and like appliance type stuff. Literally like low power enough to not even need fans. They're all passive cooled. I am extremely eager for those SkyMont cores to start migrating to those things.
Yeah, and I think that's the kind of thing that'll come over time. Like Intel launches 4 or 5 CPUs, 6 CPUs, and then they'll roll out 100 different variants in all to fill every available market niche.
Yeah.
Okay, so big deal this year. No more hyperthreading.
Yeah, I wish I understood CPU design better enough to understand why this is apparently a good thing and not a bad thing.
Well, so it used to be that the P cores had hyperthreading and the E cores didn't. So hyperthreading basically lets you segment off different parts of the CPU and do disparate tasks on the same CPU as if they're two virtual CPUs. Basically, is the easy analogy. The upshot is that the overhead of hyperthreading makes the CPUs a lot bigger, and they were able to pack more in if they got rid of it, is my understanding of the situation.
Okay.
And also with a whole shitload of E-cores. So just to be clear, the high end part here has 8 P cores and 16 E-cores. My guess is that the overhead of having hyperthreading was less efficient than having just more E-cores jammed into the same space.
That makes sense. I mean, that's still 24 threads. Like that's not really anything to scoff at.
Yeah. Well, because the thing is, if you're doing the same kind of math with hyperthreading on, it can't use different parts of hyperthreading only works if you're using different tasks, different kinds of math on the same parts of the CPU. If you're doing the same math, it doesn't scale. And a lot of the heavily multi-threaded workloads are going to do the same math, just lots of it. Right. So the AI stuff and things like that. Integrated graphics are the Xe LPG architecture, which is like a mini ARC stack from their desktop parts.
Yeah, or from the cards, the GPU. Because Intel's kind of been
discrete parts.
Stronger push in graphics cards the last couple of years, which like sounds like that's kind of paying off. Like they're still not super competitive with NVIDIA and AMD, but they're getting better.
I mean, I think the baseline for integrated graphics is way up from what it was 4 years ago. It's not the Battle Mage stuff that's in Lunar Lake, though. It's worth mentioning.
Okay. I want to say, I thought I saw people were talking like these integrated graphics are getting into like kind of low end 10 series NVIDIA performance levels now, like a 1060 or something, which like
8-year-old video card seems about right for integrated graphics.
Yeah, which is like not nothing. I mean, you could play Fortnite on that, right, at low settings.
Yeah, I mean, you can play Fortnite on a Switch if you want.
Sure.
It's 2 GPU cores. I would describe it as fairly underwhelming. But,
I mean, you know, obviously anybody who's serious about games still wants a graphics card, but it's great for embedded situations or use cases where you don't want to put a graphics card in.
And the real reason you buy a chip with a GPU on it is because you want quick sync support, which has AV1 now.
Yeah. You can now do AV1 encode with their video encoder on here, which is going to be huge for streaming and Plex and all kinds of stuff.
Yeah. If you it also includes, this is worth mentioning, the AMD parts don't include NPUs this time.
Really?
This does include the Arrow Lake NPU, which isn't fast enough to get the Copilot Plus features turned on.
Oh, no kidding.
It's only 13 tops, but it is in there. So congratulations. I think it's probably they specifically said if you care about that kind of performance, you're probably going to put a discrete graphics card in.
Yeah.
And it wasn't worth taking up die space on NPU core stuff to get it to the 40 tops that Copilot Plus requires.
Can you run all the Copilot Plus stuff on a graphics card?
Oh no, of course not. Why would you do that?
I was gonna say, like, I hadn't heard that. Like, I don't know why that's the case, but
to give you a sense of scale here, this is a 13 tops NPU. 4060 is 240-ish tops of perf.
Okay.
So that's the lowest end NVIDIA 4 series card that's available today.
Do you have any idea why you can't use a graphics card for those features? I'm not saying I want to use them necessarily.
Microsoft?
Is that just an arbitrary restriction?
I'm going to go ahead and tell you, you probably are okay not having those features.
Again, I don't want them. I don't care. It's just conceptually, it doesn't seem to make sense why you would block that off.
It's I don't understand that. It's a weird choice by Microsoft.
Yeah. I mean, it goes back to, like, I wonder about things like this because you remember the days of which DirectX did they lock up to Windows Vista? Was it 8? No.
8.
10?
No, 8.
Wait, DX8. Anyway, the point is Microsoft has a history of, I think it might have been 10. I think it was DX10 that you had to, because I forget which Halo it was that you had to get.
Halo 3, right?
I forget. There was some, anyway, it's been a while. But Microsoft has a history of arbitrarily locking features behind new Windows versions, which just made me wonder if there's something going on here.
Yeah, DirectX 10 was Vista only because you needed WDDM graphics drivers, which is a kind of like, that's a choice, but whatever. Anyway, my guess is that this is more, we just haven't built the APIs for this to work with the GPUs at this point.
That also is believable. And
also the kind of things that are Copilot Plus features are so like low power required that it's massive overkill to put a 4990 or something on it. Anyway, the new chipset, because it's Intel.
Yes, new chipset, new socket.
Intel's move is always new chipset, new CPU socket. They haven't done it for the last like 3 releases of Core i9, Core i parts.
Yeah, well, 12th, 13th, and 14th gen all work across the same motherboard, which is extremely out of character for them.
That is literally the longest run I've ever had an Intel board last.
I assume they make a decent amount of money on their chipsets.
I think that they just want to keep selling new motherboards every year when they sell. Yeah,
well, that's probably. What I mean. Yeah. Like they're making money selling chipsets to motherboard makers.
Yeah. So the new chipsets is Z890, the new sockets LGA 1851. I would assume that you're never going to get another generation of CPUs that goes in this socket or this chipset when you buy these boards.
Probably not.
Which is fine. I mean, that's how most people. That's how computers work for most people, right?
Yeah.
The parts are the 285K, which is a 5.7 gigahertz max at $590, unavailable everywhere. It's 8 P cores, 16 E cores, 4 GPU cores, and the NPU.
Wait, you're saying it's sold out? Like you just can't find it right now?
Can't buy them.
Really?
Yeah.
Weird. Because I mean, we're getting into it in a minute, but considering the drubbing this thing took in the press, maybe they just didn't make a lot of them.
I think they put them all to the OEMs.
Okay.
The 265K and KF parts. KF parts, as a reminder, are unlocked, but with no GPU. Are 5.5 gigahertz max, 394 for the K, 379 for the KF. So you save like $15, not getting an integrated GPU and probably a little bit of thermal overhead. 8 P cores, 16 E cores, and 4 GPU cores, except for in the F one.
Oh,
and it has the NPU.
Of cores.
Same number of cores.
Oh, that's interesting.
Clocked down a little bit.
Okay.
Just a smidge. And then the 245K and KF, again, no graphics on the KF, 5.2 gigahertz max, and it's 6 P cores, 8 E cores, 4 GPU cores, and the NPU. And the K is 320 and 300 for the no graphics F part.
KF.
Yeah. All overclockable, all unlocked, so you can overclock them. And again, this is a situation where they'll fill out more CPUs. That most of them will probably just go to OEMs, but these are like the enthusiast box parts.
Yeah. So is the 245K what you would think of as an i7? No, because that's 6 cores. Like typically the i7 is like the same number of performance cores and just somewhat smaller E cores. Look, I feel like there's still room for an i7 equivalent in this lineup. There
are some weird holes here. Also, they used to do things with hyperthreading and not hyperthreading. And I want to say like i3s didn't have hyperthreading or something like that. Like, it's a brave new world. We're going to talk about what's weird here and where there are big perf holes. I think that they priced these based on perf. would be my guess compared to previous generation.
Okay.
They're pushing power consumption with the like all of their marketing for these was about power consumption because the power consumption bit's real good and perf is kind of especially like if you compare it to 9000 series Ryzen, it's pretty meh if you compare, which was already meh. And if you compare it to Raptor last generation 14th gen Raptor Lake, it's real double meh.
That's so damning. Like not being great against your competitors' contemporaneous release is one thing. Not being great against your own previous generation is really hard to swallow.
Now, okay, so there's some asterisks here, right? It's real good in workloads that use a buttload of threads, right? So like Cinebench, Handbrake, video CPU transcodes, things like Premiere does real well. It's not good in games because the clocks and the thermals are a little bit constrained compared to the 14th gen Intel. And it gets its ass kicked by the 3D cache AMD parts.
Yeah, but to be fair, everything does.
Yeah, like the new Ryzen stuff did too until the 9900 was out.
I had thought about trading up to an Arrow Lake until I saw the game performance stuff, and that's just a little hard to swallow.
I mean, now the thing that's worth mentioning is when you're getting 14900K performance out of this thing, it's drawing like 30% less power in a lot of cases.
Okay,
so like you're basically getting, this is basically the Intel equivalent of what we saw with Zen 4 last go round or Zen 5 in terms of power consumption, right? And when you compare, the place that's interesting when you're doing the power tests is the idle draw for Intel is way, way, way lower than the idle draw for AMD.
Really?
And we're honestly, we're working on ways to like show this in benchmarks because it's a little bit tricky. But like if you're thinking about a normal workload where you're using your computer, it's idle most of the time for most people, right?
Or 80 to 90% of the chip is idle, like 1 or 2 cores are active at any given time.
Yeah, and like the idle draw on these Intel chips was like 90 watts versus 120 or 125 for the comparable Ryzens. So like it's a significant amount of power over a long period of time if you're talking about like not running full bore. Like if you're running full bore all the time, the AMD chips have a little bit of an advantage. If you're running normal human computing workloads where you sit in front of your computer and doing some Zooms and doing some emails and then playing a game, probably it's going to be a wash at best and probably favor the Intel side.
Yeah.
The gaming perf problems here are probably due to memory latency is what the consensus was amongst reviewers. The memory controller is on its own chiplet. It's not integrated in the compute chiplet, which was like my assumption there is that that's a design choice to get more more CPU cores on the same, more compute wafer chips out of each wafer, because those compute chips are the expensive wafers from TSMC.
Right. Now, I have not lived in this world for long, like you've been in it for 30 years or whatever, but like the iterative hardware review kind of thing. Yeah. But even I have seen enough like slide decks and been in enough presentations to suspect like maybe the next generation of this thing, like that's a prime candidate for like we've improved the memory controller some X 20% or like that's one of those things that'll be like, or more broadly, that's one of those optimization points where there's something they didn't do as well as it could have been done, but that they will improve and iterate on in future generations.
Yes. So the thing to remember with all of the CPU stuff and GPU stuff too is that the pipelines for design and building these things are years deep. It's 5-7 years in some cases. So they aren't going to realize that this is a bottleneck until they start seeing the first runs of chips off of the actual fab, because you can't actually sim these anymore because they're too complicated.
Right.
So like they get the first ones back, and by the time they get those first chips back off the line, it's too late to make any significant changes. So they're not going to realize that, memory bandwidth is going to be, latency's janky. They also had some problems we'll talk about in a minute that seem to be Windows and or BIOS related issues. So anyway, to your point, yes, this is, I would assume, if not the next generation, the one after that, we'll see a significant change in the way the memory latency works. And we may even see some substantial improvements in the interim. don't buy stuff based on future promises. This is always the rule.
Yeah.
The other thing that's worth mentioning here is that all of the chiplets tiles on their disaggregated design, almost all of them are overclockable independently, including the base layer.
Oh,
so you can overclock the SoC, you can overclock the IO tile, you can overclock the Foveros connection layer. Like you can go ham. They put all the dials into this thing.
They expose all the settings for that stuff?
Yeah.
That's crazy.
Yeah. So I mean, you have to have the right board. But yeah. So we haven't tested any of that stuff yet.
Overclocking the base layer, which does nothing but facilitate communications between the other tiles, is hilarious.
Well, but if you think about it, if it's memory latency and memory bandwidth that's the problem, then overclocking that actually might have a significant improvement.
Totally.
Don't overclock your, like, this is, let other people figure this out.
Yeah,
Don't do it with your CPUs.
Like, I've never, ever in a million years do something like this, but it's pretty funny that it's possible.
Yeah. And we talked about this before, but like, this is the most complicated, biggest change in the way these CPUs are built for a long time. So I would have been shocked if this thing came out as this is the fastest thing we've ever seen. When Ryzen's came out, the thing that they had going for them is they had a buttload of CPU cores, and a whole bunch of weird issues when you were doing things that needed like communication between dies and stuff like that. So it's to be expected.
Like it's actually, I mean, I feel like, I'm not saying you should go out and buy one of these because, like, at the end of the day, performance is what it is, but it seems somewhat impressive that it actually did come in at some, like, reasonable level of performance, and, like, so far not a ton of, real deal-breaking issues.
I mean, that's the thing, is, like, if you're a normal user and just doing computing stuff and encoding some video and stuff, you're not going to notice these problems. Like, this is going to feel fast. If you're upgrading from 11th gen Intel to this, it's going to feel fast as hell, right? Yeah. It's only when you're comparing it against everything else that's on the market that it feels slow. And if you're spending money and you care, then you should buy the thing that's fastest for what you do. Yeah,
like, to reiterate again, if you want to build a gaming machine, get a 9800X3D once you can get them.
That seems right.
But again, just conceptually, or in terms of laying foundation for the future, like, the fact that this thing works generally is a good sign.
It's very exciting, especially given the problems they had with Raptor Lake.
Right.
So in our testing at PC World, we found some issues with power settings. Other people corroborated this. So, that setting that you have in Windows, you can say most efficient, balanced, or most performant.
Yeah, a little slider.
If you're not on most performant, weird shit happens. So, for example, at the balance settings, we saw like a significant double-digit performance drop across pretty much every CPU benchmark.
Yikes.
When you're on the most efficient settings, it just ran everything at idle for single-threaded benchmarks, so it never clocked up the boost clocks on the CPU core. This is stuff that they'll fix over time for sure.
That seems like a pretty egregious oversight.
I mean, this is the kind of thing that happens. Part of this is that Windows 11 24H2, which is what everybody tested on, came in a little hot and reworked a lot of how this stuff works. But yeah, I was shocked that we had these problems. I wouldn't have expected this at all. And I wouldn't buy these until they resolve that. The edge case. Oh, this is your question.
This is, so I guess we could just talk about this now.
Hit me.
What I'm curious about, and again, I had thought about trading up to one of these from a 14900K until I saw some of the benchmarks.
Mm-hmm.
My question is, I am limiting the power on my 14900K. I'm not running it full bore because I'm still on an air cooler.
Okay.
So like, for example, it boosts up to 253 watts, but I've got it capped at 190 just because basically you need liquid cooling to actually handle 253.
Okay.
So I'm wondering how my power limited 14900K would compare to a 285K at stock, since it runs better at lower wattage, higher efficiency. You know what I mean? Like, you're getting more performance per watt on the newer part. So I'm wondering, like, obviously pound for pound, it doesn't measure up very well, but if I'm running the 285K at its full capacity versus a 149K that is limited by 20% or more, I wonder if I would actually be coming out ahead on the newer one.
Well, so the max. Okay, so first off, I don't think I can answer this without actually doing tests.
This is definitely this is not a, like, what should I do? This is more just a general thought experiment, like, conversation starter.
The thought experiment is that the reason you're doing that is because you're on an air cooler, right?
Yeah, like, it was hitting 100 Celsius. It was throttling constantly in games at max power draw.
Yeah, so you're going to have the same thermal limit, and the 285K does go up to 250 watts, I think is the max TDP for boost.
For boost. Okay.
Yeah, so you're going to hit a limit somewhere in there.
Okay.
It doesn't hit boost a whole lot. Like
interesting.
It was I don't know. We put it on the real answer to your question is that you need a big water AIO.
Yeah, I know.
Yeah. Like air cooling is not the right thing for top of line CPUs these days.
It's so much simpler though.
In some ways, in other ways, I've never looked at my PL1, PL2.
Fair.
Yeah. But my guess is you'll do more at that thermal at the same limit than you would on the new chips.
Yeah.
I mean, the new chips you'll get more work out of the same amount of watts on the new chips. I believe.
Is it enough more to warrant the upgrade? Probably not.
No, absolutely not.
Probably not.
Like here, the real TLDR out of all this is that if you're upgrading your CPU every generation, you're just kind of wasting a lot of money.
Yeah.
Because like the 7800X3D is going to end up being the same level of performance as all of these chips except for the 9800X3D, right?
I think even isn't the 5800X3D still like pretty competitive?
The 5800X, if you have a 5800X3D, you're doing great.
Yeah.
Yeah. So, okay. So the other thing that comes with this new chipset and this new CPU is CU-DIMM support. This is a new memory standard. It basically adds this clock driver chip to the DIMMs that generates the timing clocks for the RAM on the RAM stick itself instead of taking it from the rest of the CPU. The practical upshot is that you're supposed to be able to run much, much higher clock speeds on the RAM. And like the JEDEC limit is like 6,400 megatransfers per second, I think. If you want to do some crazy shit, you can get all the way up to 8,400. There's some big caveats in that you have to adjust some ratios so that the number of transfers per cycle go down and stuff like that. You might have to run them in single channel mode, which means your clock speeds will go up, but your effective bandwidth will go down. So it's early. Yeah. This is what I'm going to say.
I was going to say, like, this sounds like a good improvement in the long term. Like, obviously, new stuff like this is never quite where you want it to be right out of the gates. But the problems they've been having with DDR5 stability generally since DDR5 came out, like, clearly this was necessary if they took this step. So it seems like a good thing for the future.
To be clear, DDR5 stability at JEDEC speeds, no problem.
Oh, yeah, sure.
DDR5 stability at 7,200 megatransfers per second, not great for most people.
But, if you go back and look at the DDR4, like what was the JEDEC was like 2133, I want to say, or maybe 2400 for DDR4 out of the gate. But people were routinely getting up 3600, pushing 4000 without issue. So like the point is there was just a lot less headroom on DDR5 until they took a step like this, it seems.
And this is the path, right? Like it's funny. I was working on an old 9900K machine the other day. And I was in the BIOS and I was like, oh, let's put the XMP on for this and see what it's 3,600 megatransfers per second. It's a entirely respectable machine still, but yeah, this is the path to higher memory clock speeds. And my assumption is we'll see better support and performance in the future. Now, it fits in the existing slots. If you plug in one of these chips into a BIOS that understands that these chips can be on the DIMMs, it'll say, hey, we're going to turn off the CU-DIMM chip, the clock driver chip. So this is just normal DDR5 that'll run at JEDEC speeds.
So it's backwards compatible is what you're saying?
Kind of. The BIOS has to understand it.
I see.
Right now, you're not going to, there's only a handful of BIOSes that understand. We plugged into a bunch of machines that were in the lab and it was weird every time.
Interesting. Okay. That's good to know.
Yeah. So, you don't have to make this choice and do it now. When the kinks get worked out, you can do it later if you're upgrading memory at some point in the future or something.
Are these widely available yet?
No, there's like one kit in the world.
Okay, so it's that kind of launch.
I don't even know if they're selling it. They might have just sent us kits.
Interesting. Right. Okay, because I wanted to know what the pricing. I wonder how much more these might be with an extra chip on there, but I guess we can't quite say yet.
I'm going to go to Newegg right now and see if you can buy CU-DIMMs. I think when I searched this the other day on the Full Nerd, it came up with CU-DIMMs because it thought I was typing something wrong.
Here's a crucial. This is on crucial.com.
Okay.
32 gigabyte, 16 by 2, DDR5 6400 CU-DIMM, $170.
Okay. Here's a 48 gigabyte kit from Manta V-Color Manta Xfinity. 48 gigabytes CU-DIMMs 8800 mega transfer for $400.
Wow, but that's 8400 though. That's
8800
or 8800. Sorry, that is extreme bleeding edge RAM speed right now.
Yeah, the 8200 are 269. I wouldn't. Here's the thing. This is going to be janky for a while, right? Like this is a let everybody else figure this out situation.
Yeah.
Not a you should do this today situation.
Here we go. Okay, this is what I was trying to find an apples to apples comparison, and I have found it.
Okay.
Here's a similar crucial DDR5 6400 kit, 32 gigabytes for $119.
Okay.
On their site.
Mm-hmm.
So it's $119 for the regular DIMM or UDIMM, the CU-DIMM.
For what size?
It's 16 by 2.
Okay.
The exact same 16 by 2 6400 in a CU-DIMM is 170 right now. So there is actually a pretty
hefty price bump. Yeah.
Pretty big premium on that at the moment.
Yeah. So anyway, like let them figure that out. Don't worry about that right now. Just buy normal DDR5 and run it like 6400 and you'll be fine.
Yes.
So Intel has said this isn't the performance we want out of this chip and we expect out of this chip. We think that there was some things wrong with the BIOSes and OS configuration that we're working with vendors to solve.
Also, I just found this morning. The weird thing is, so this is reported by videocards.com with a Z.
Yeah.
They linked to, this is an interview that supposedly Robert Halleck, Intel vice president, did with Hot Hardware.
Okay.
The odd thing is it's a YouTube interview, and when I click through, the video has been pulled.
Weird.
But I do have the quote they pulled from the video here, if you want me to read it.
Yeah, go for it.
Even though the video is no longer up, and I'm not sure what's up with that, but here's the quote they pulled out of the video. I think what people have been interested to hear is what happened. I can't go into all the details yet, but we identified a series of multi-factor issues at the OS level, at the BIOS level, and I will say that the performance we saw in reviews through no fault of reviewers is not what we expected and not what we intended. The launch just didn't go as planned. That has been a humbling lesson for all of us, inspiring a fairly large response internally to get to the bottom of what happened and to fix it. So
look, what they should do is they should set the microcode to keep increasing the voltage.
There you go.
Every time there's more demand until it hits just infinity.
It's just crazy enough to work.
Yeah.
So I don't know. I don't know if who or what caused that video to go down, but I assume we can still take that quote at face value.
Weird that it got pulled.
But you know, the upshot is AMD had the same thing where they had to put out a Windows update, right, to improve performance, and now it looks like Intel might be doing both OS and BIOS updates to try to help things here. I guess is that just the world we live in now? Like, or is it just like it? On one level, it seems insane to me that companies as big as Intel and Microsoft and AMD would not all be collaborating enough behind the scenes to get things working properly before they come out. But is like, have we just reached a level of complexity where that's not realistic anymore?
I think that's the problem. So for what it's worth, there's another video that's a live stream that has Robert Halleck talking to Hot Hardware.
Okay, maybe they took down the live stream archive and put up.
They might have put an edited version up.
Okay.
Anyway, I think to your point, the hardware is really complicated. Like these disaggregated designs are complicated in a way that Windows and software aren't necessarily equipped to deal with right now. Both because of the differences in the P and E cores on Intel and because of the communication across dies on the AMD side. These are all difficult things. And a lot of the underpinnings of Windows are based on, hey, all CPU cores are the same. And that's no longer the case.
CPUs got weird.
CPUs are weird.
CPUs got weird, and it's all a reaction to the practical limits of silicon, right? And how much you can just increase clock speed. Like these are still just further effects of we have to find other ways to make CPUs faster, right?
Well, I mean, yeah, you say that, but also the process techs do keep still getting smaller, even though we thought we'd hit walls years ago.
Yeah, but it's pretty minor, you know, like we're slowly edging up past 5 gigahertz reliably.
Yes,
towards 6.
I mean, I think the thing I'm curious about these days is how much performance can we get out of, like, how much work are you getting for each watt? that goes into the CPU now, right? And folks like Steve over at Gamers Nexus and other people have been doing some really interesting tests by isolating the rails, like the power going into the rails that the CPU uses, to actually see how much wattage each benchmark run costs. And I think for me, the fact that our solution isn't just, well, you can get 16 or 1800 watts out of a 120 volt, 15 amp circuit, and we can just keep dumping that into the CPUs and they'll keep getting faster, isn't a sustainable solution.
No,
and it's good that everybody is moving in that direction.
I am extremely happy with these CPUs, even whatever issues they have individually. Just generally, it looks like the race to the top on excess voltage and trying to come out 0.1% ahead on benchmarks is finally ending.
Now, the bad news is that the GPU side hasn't reached this conclusion yet. So whatever savings we get out of CPUs is just going to get absorbed by the GPUs.
Yeah.
Until I think one day, the Jensen's vision of the computer is just a giant NVIDIA GPU that you drop a CPU and some RAM into, right? Mm-hmm. Anyway, rough launches, they're rough because they're complicated products, I think, not because there's no... Look, the internet, let's see, Gordon over at PC World likes to pull out the jump to conclusions, Matt, and get everybody on their outrage ponies and get everybody mad about stuff. I think that this is just, testing this stuff is increasingly difficult. Like I spent a lot of time running benchmarks over the last couple of months, and it's not, in the old days, you could run a benchmark and then you could change the front side bus multiplier or the front side bus speed or the multiplier and kind of test how things were running to test your assumptions about what was going on inside these chips. And there's so many things going on now that that's not as much the case anymore. You just really can't do it.
Yes. There are way more knobs.
To the point that I think even sometimes internally, like between the OEMs, the OEMs making the motherboards and the CPU manufacturer, there's even miscommunications about how stuff should be set up, as we saw last generation on both sides.
Right. I think that's maybe to amend the thing I just said about the fact that these giant companies aren't getting products out working as well as they could be. I think that's the more surprising thing to me, not that they are not shipping them in an optimal state. They don't even seem to know that they're not in an optimal state until the reviews hit and they're like, oh, we don't even quite know what we shipped and all ins and outs of it yet. But I guess that's just the nature of both the complexity and also the timelines of the launches they're working on. Like, who knows how much internal time they even have to fully test them and get familiar with everything before they hit the market.
Well, and the timelines for the reviews are, I don't want to say compressed, but it's like if you have 5 days with a set of 2 or 3 CPUs, you're really lucky. And typically you get one motherboard. So if you do a CPU test suite that takes 12 hours to run, like it's challenging.
Yeah. Right? This just strengthens my growing feeling that maybe wait like 6 months after launch before buying a new CPU these days.
I think that's safe advice for literally everything, unless you really like NVIDIA Founders Edition cards, which sometimes are no longer available after 6 months.
Fair.
But yeah, I think that's as good a place as any to wrap it up, right?
Yeah. I've done this. I'm optimistic. I've been pretty bummed out at the state of CPUs for the last few years. Like part of it was like I said, everybody is just burning the things out, trying to make them look better on paper, and also like the COVID disruptions seem like they caused issues with design and testing and blah blah blah. Like it feels like all of that stuff is finally settling down, and both companies are laying good groundwork for the future for things to get better. I agreed. I think the stuff that's going on with the Ryzen side is really, really exciting. I'm super curious about the X3D versions of the dual CCD chips now, because the delta in clock speeds on those dual CCD ones between the Vcache one and the not Vcache one should be a lot lower, which I think will solve a lot of the thread parking and weirdness problems that we had with the last gen ones. But also that 9800 X3D is just a dope part if you play games. It is so freaking fast. Yeah.
The Intel stuff, whether they work out the kinks this generation or next, like I know they're going to continue to work on this generation until it gets to a point where they're happy with it, right? Don't buy it based on that, but like they spend a lot of money building these chips and they need them to move.
Yeah. And with those comments about BIOS updates and Windows updates, like maybe in 6 months, like the Arrow Lake looks more appealing.
Well, what I was going to say is the other thing is I think that the basic premise of, hey, we're going to do these low power chips and we're going to get good performance out of them is panning out. The Xeon, the server side of this reviewed much better than the desktop has.
Right. And
the Lunar Lake is killer. Like on the mobile side, the TLDR is that unless you're running corporate stuff and really don't want third-party software to be compatible, don't buy Qualcomm, right? There's basically 3 chips on the mobile right now. The Qualcomm ARM-based Elite X, Lunar Lake for Intel, and the Ryzen AI for AMD. The Ryzens are a little bit more performant, but use a lot more power. Not a lot more power, but significantly more power. The Lunar Lakes are basically as power efficient as the ARM processors, run all your software and are hella fast.
Yeah, that's great. Like Lunar Lake sounds killer if you need an x86 laptop.
Yeah, so like it's we're in a good place. It's we're in teething pain territory here.
Yes,
so.
Yes. One last thing I was going to mention. I thought I had seen this rumor, and sure enough, I have pulled up. I mean, it's still a rumor, but it's at least being reported by reputable sites.
I love a good rumor
on the two CCD X3D parts. So the 16 and 12 core. The rumor is both of those CCDs are going to have Vcache this time.
That I would be shocked if that is the case.
But that's what's going around.
I would be shocked if that is the case.
Well, but at least the clock speed disparity will no longer be a problem.
I would be shocked if that is the case.
I mean, I also don't fully. I mean, I'll believe it when I see it because it would be more expensive.
I would be shocked if that is the case, Brad.
We'll just leave it there.
Yeah. And speaking of leaving things there, I guess this is the time when we thank everybody for listening to the show and supporting the show. Brad and Will Made It Tech Pod is a listener-supported show. We wouldn't be here without you all, the listeners. So if you want to find out how you can support the show, you can go to patreon.com/techpod. Again, it's patreon.com/techpod. And I'm supposed to say it 3 times is what Patreon tells us. They say the call to action 3 times so that people make sure they get that URL. So that when they're in their car, when they're sitting in front of a computer the next time, they think, oh man, I should go to patreon.com/techpod and give Brad and Will $5 so that they keep making the show. Because we don't run ads here. Oh. This is all listener supported. We do this because of you, the listeners who we appreciate for taking good care of us.
And you get a whole extra podcast a month.
You get 1 extra podcast a month. You get access to the Discord.
That's right.
Where you can look, maybe we need more community than ever now. It's a good place to get into a good community of good people.
Yes.
Like it's
good people. And if you need a distraction,
Yeah.
Also, if you want a place where, for example, if you're thinking about getting a virtual private server and running a proxy to your house to run Quake servers and Plex and all that stuff through.
Yeah.
I'm throwing that out there as an example. The point is, if you have a thought that you're like, I wonder if I could do X, Y, and Z project. I wonder if this would work. I almost guarantee you that no matter the domain of the project you're considering, there are people on there who can answer the question or have advice
or have been in had similar thoughts and can talk through it with you. Yeah. So you go to patreon.com/techpod. You give us $5 a month. You get access to the Discord. You get the patron exclusive episode every month. And if you're an executive producer, you get thanked every single episode, just like Andrew Slosky, Crow, Jordan Lippett, Bunny Fiend, Twinkle Twinkie, David Allen, James Kamek, and Pantheon, makers of the HS3 high-speed 3D printer. Thank you all so much.
Yeah, thank you.
And we will be back next week with another edition of the Tech Pod. Thanks for listening, everybody. We'll see you all then. Bye.